In this video, we're doing an infinite series question. So part A is to find a power series for y of x equals e to the x plus ln of 1 minus x minus 1, and x is restricted between negative 1 and 1, and x can be equal to minus 1. For part B, we're going to find a power series for y evaluated at x equals minus 1. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, we have e to the x plus ln of 1 minus x minus 1. Okay, let's look at e to the x minus 1 first, since those are pretty easy. So e to the x will be the sum from n equals 0 to infinity of x to the n all over n factorial. So let's plug in the first term, so that would be n equals 0, so that would be x to the 0, which would be 1 for any x bigger than or equal to 0, because even power series, 0 to the 0 is 1. So this is 1 plus the sum from n equals 1 to infinity of x to the n all over n factorial. Then we can subtract 1 on both sides, leaving us with e to the x minus 1 equals the sum from n equals 1 to infinity of x to the n all over n factorial. Okay, good. Now let's look at ln of 1 minus x. And we don't have to worry about absolute values, because between minus 1 and 1, it's always bigger than 0. Because even at x equals 1, you have ln of 1 minus 1, which wouldn't even happen anyway, so it's bigger. Yeah, so it's always positive inside the ln. Okay, 1 over 1 minus x will be the sum from n equals 0 to infinity of x to the n. Now we're going to integrate both sides with respect to x, but really we can integrate inside the sum because it doesn't have to do with x. So this will be the sum from n equals 0 to infinity of x to the n plus 1 all over n plus 1, and then we'll use parentheses to say that this plus c is not in the sum, because that's important. Okay, the integral of 1 over 1 minus x will be natural log. As we said, it'll be always positive, so it'll be 1 minus x, the inside. Then we have to divide by the derivative of the inside, which is minus 1. Okay, so now what can we plug in to get the c? So we know that ln of 1 is 0, so let's just plug in x equals 0. So on the left-hand side, we're going to get 0 equals the right-hand side. What do we get? So we're going to get 0 to n plus 1. N is bigger than or equal to 0. So we're never going to get 0 to the 0. We're going to get 0 to the 1, 0 squared, so on. So this is 0 plus c. So obviously c equals 0. So we have, now we're going to multiply negative 1 on both sides, leaving us with ln of 1 minus x equals, so we're multiplied by negative 1. So we're going to have negative 1 times the sum, so it would be the sum from n equals 0 to infinity of minus 1 times x to the n plus 1 all over n plus 1. And this is why we start at n equals 1 on the other sum, because it's just easier to look at. So we're going to move n to n plus 1. So this will be the sum from n equals 1 to infinity, the minus x. Now the other n's, we're going to move back to n minus 1. So it would be n plus 1 will go to n, and then n plus 1 will go back to n. So it'll look like this. So this is ln of 1 minus x. Now we can add e to the x plus ln of 1 minus x, and then minus 1. Then we know what these are. This is a different part. This is above. This is all the way up here. So this. Okay. So we're going to start with that. So this is equal to the sum from n equals 1 to infinity of x to the n all over n factorial. And then we're going to have this sum. So we're going to have minus x to the n all over n. Okay. So what are we going to do with this? So we're going to say the sum from n equals 1 to infinity. For this kind of question, we want to take the x to the n out and then combine some stuff. So we have one fraction too. So it looks better too. So we have all over n factorial, and then multiply by x to the n, because we have x to the n in both terms. So on the top, for this one, we're going to have 1, because we're only taking out an n factorial. But for here, so we have n. So let's multiply top and bottom by n minus 1 factorial, because n times n minus 1 factorial is n factorial. So this will be minus n minus 1 factorial. And then just for clarity, all this is multiplied by x to the n. So this is part A, is the answer. But we can kind of do more. So let's look at this. So before n starts at 1, But let's plug in n equals 1. So n equals 1, we have 1 minus 0 factorial, but 1 equals 0 factorial, so this cancels. N equals 2, we have 1 minus 1 factorial on the top, but that cancels. So we can actually start this at n equals 3. Let's just make it look better. Okay, so that's a cool fact. So part B, and this is y of x. Okay, so y of minus 1, right? Yeah, y of minus 1 will be the sum from n equals 3 to infinity. We'll just plug in -1 for x. So this will be 1 minus n minus 1 factorial all over n factorial. Just use brackets to distinguish it. And then I'll multiply by -1 to the n. Now this is equal to -1 plugging into this function right here. So this is e to the -1 plus, okay, ln of 1 minus -1 is 1 plus 1, which is 2. So that's ln of 2 minus 1. 2 minus 1. So that is part B, and that is a nice fact, and that is the end of the video. Hope you liked it, and thank you for watching.